Started.
A very good afternoon, everyone. We're going to start the session today, and this session will be taken by Dr. K. Rubinraj sir. He is completed his BTech in Information Technology from the Village of the Institute of Technology, JNTU, Hyderabad. He earned his MTech in Computer Science Engineering from Hyderabad Institute of Technology and Management, JNTU, Hyderabad, and completed his PhD in Computer Science and Engineering from Sri Vejati University, Rajasthan. He has over 17 years of experience in academic and administrative roles across various institutions. Currently, he is working as an associate professor in the Department of CSE AIML at St. Martin's Engineering College, Hyderabad. Dr. Rubinraj also has industry experience as a reverse engineer at University Industries, Private Limited, and at Daniel Oil. Sir, I wish to please cover the guidance and continue the session.
Thanks for everyone. Good afternoon, everyone. Thanks for giving me this opportunity. First of all, Dr. Lakshmana and all the coordinators of this program, and I'm appreciating all the participants as well for participating in this portion. Okay, coming to our topic. So our today's discussion is about neural networks, types of neural networks, meta-heuristic approaches. That is
sound package. Adi close.
So these are the topics which we are going to discuss on this neural networks. Neural networks. introduced first, inspired by human brain. So, what the subject is, main intention, it is inspired by human brain. Okay? See, as a human being, whatever the object or anything, if we wanted to see, immediately the communication is passed from our brain to all the parts of the body. Is it right or wrong? So, in between, what is the reason behind it? The reason is at core neurons. Neurons. So, what is meant by this neuron? So, these are all biological neurons, right? Biological neurons. Okay, I'll show you the architecture of the biological neurons and how biological neurons and what concept of this neurons of biological and in what way it is inspired in computer science and what are the ways to communications are possible that we all see in our topic is called neural. You are following me, right? Okay. So, see, neural networks are networks of interconnected neurons. See, I am saying all about the biological neurons perspective or biological neurons perspective. So, I wanted to show you. Yeah, look at here. The basic components of the biological neurons. The basic components of biological neurons. So, in this biological neurons, we will be having the different parts. Okay, so these parts mainly we are having cell body and we also called as soma and neuron nucleus, dendrites, axon and synapses. Okay, so the whole control of the neuron, the whole control of each and every neuron is controlled by this cell body, so that is soma. So what the cell body will do, it processes the incoming activations and converts them into output activations. See, the main concept of this biological neurons, which will pass the electrical impulses or electrical communications to one neuron to other neuron, one neuron to other neuron. So, based on this communication, one neuron to other neuron, and the signals will be passed from the brain to all the parts of the body. So, once the brain is giving the command, right? So, according to that command, the parts of the body is going to be do their works. Is it right or not? Suppose, for example, if a human being wants to classify two diagrams. Let us assume there is a picture. The picture name is called a dog and a cat. If I show any human being to identify these pictures, immediately it will be classified, right? So this is the picture is it's a dog picture. Okay. And the other picture is cat. So once the human brain is find the particular object, immediately how does it know? It is a cat picture, and how does it this is a dog picture. By seeing it, immediately it is all controlled by the brain neurons, and is going to be recognizing the particular cat or dog. Is it right or not? So when it was get trained, when the human being was get trained, so at the time of development, at the time of human development, right? Brain development process. So at what age from the human brain is going to be developed from the childhood onwards, right? Okay. So based on this concept, this neural networks has been introduced for us So in our subject, is we are going to be creating any biological neurons? We are going to creating any biological neurons? No biological neurons. It's completely neuron. Here the neuron stands for just like a variable. What the variable will do? In our programming languages, a variable can hold a value, right? A variable can hold a value. It is a temporary memory space. This is right or not? Okay? So, just like our neuron, whatever the neural networks which we are introducing in our computer science and engineering, it is all artificial neurons only. Artificial neurons, not the biological neurons. Okay? The basic of the basic information of the neuron is it is a just like a variable. So variable can hold any value, just like integer value, like it can be integer value or a float value. But whatever the neuron we are discussing, right, it can be holding a float value. A float value. So float value is what? So it's in programming language, data type float can take 4 bytes of memory. Is it right or not? So in Java as well as every programming language, float is 4 bytes of memory in the date and it can hold the pointwise numbers. Right? So just like we are following that concept. So coming to the neurophysiology of the biological neurons, look at here what is happening. The human nervous systems can be divided into 3 stages, that are receptors, neural net and effectors. So here the receptors will do, almost following me, right? The receptors stimuli from the external environment into electrical impulses. I told you, right? Whatever the environment conditions which are passing to our brain neurons in the form of electrical impulses. Okay, now so one neuron to other neuron will be passing the information through this electrical impulses. Okay, so either these neurons will be present in different body parts, right? Let us go for eye. Let us go for our eye. So in the eye, broadside cones of eyes, or else, if you go for the skin, so pain, touch, hot, cold, receptors of the skin. So whatever. Okay, so this information, so this environmental electrical impulses can convert from the external environment to our body. And the neural net, it receives the information and process it and make appropriate decisions. Okay, and the effectors, it will convert the electrical impulses generated by the neural net into responses to the external environment and just like muscles and glands and speech generators. So like this, there are human nervous system is divided into 3 types. Okay? Yeah, we come to our neural networks. So what I told you, a neuron is basically a variable. It can holding a value. Okay, so what we are trying to do with this artificial neural networks? What we are trying to do with this artificial neural networks about? We are trying to replicate the human brain. We are trying to replicate the human brain. So how much the brain, the biological neuron system is arranged, how the biological neuron system is arranged, and how the communication part is being done with all these neurons, that type of architecture we are trying to implement in our artificial intelligence, artificial neural networks. Are you all following me, right? Okay. So the main intention of our artificial neural networks is to be replicate our human brain. Is it possible actually? Is it possible? Yes, it is possible. Yes, it is possible. If we deeply see into in the arrangement of neurons. Arrangement of neurons here. Look at here. Okay. So in this neurons, yeah, in this our artificial neural networks, in this artificial neural networks, our scientists are arranged the design of the neural networks are in the form of layer design. Layer design. Layers design. So what the layers design and what will be the the series of neurons will be arranged. I wanted to show you. Look at here. This is marker, right? Just like assume this is a neuron. So the neuron can hold what mark? A variable, right? A variable. So this is a memory space. Let us assume here. Okay. So what we are trying to do is here we are replicating our human brain. So to replicate the human brain, so we are arranging the neurons in the form of layers. Okay. So let us assume here these layers are three types. These layers are three types. The one is first input layer, and second one is output layer, and third one is what? Huh? Tell me. Hidden layer, very good. Hidden layer, right? So the input layers are like this. Hidden layers and output layers, and each and every neuron is connecting with all the neurons. Right? So each and every neuron of the layer, input layer and hidden layer are connected with the output layers, right? Okay, so here once the human being, if he can find out any object, immediately that information, and so the human being is taking as an input, and finally it is producing like it is a cat dog. It is a cat picture. It is a dog picture. Now it is recognizing with the connections of different neurons, right? So the direct connection is from input to output. So this arrangement we are trying to replicate from biological neurons to our artificial intelligence neurons. Are you all following me, right? And while creating this artificial neural networks, we are trying I will tell you. Look at here, with this artificial neural networks, what we are doing is, we are creating a mathematical model. What we are doing? We are creating a mathematical model. So, once we created this mathematical model, the benefit and the power of this mathematical model is to be creates or recognizes the pattern. This mathematical model is going to create or recognizes the pattern. So based on this logic, the neural networks are being designed and developed. Let us assume, see, whatever we are trying to creating what with the concept of neural networks, a mathematical model. Let us assume NN is a mathematical model. NN1, let us assume NN1 is a mathematical model. Okay, so this mathematical model under construction of this NN1 is a mathematical model, right? So while construction of this mathematical model, directly it doesn't work out, right? So what we are going to do is we need to be train this model before producing the outputs. So if you directly give the inputs and getting an outputs are definitely we will be not that model is not accurate. That model will not be accurate. So once we start training this neural network model, it will understand the pattern first. It will understand the pattern. Suppose, let us assume I wanted to perform addition operation. So in the period of training, what I am trying to do is I am taking two numbers and I am trying to add in it. Okay, so the summation of those numbers, whatever the numbers, how many numbers I am going to be adding, all those numbers, in the period of training, number of thousands of additions can be done in a training period. Okay, so once the all the inputs and outputs and the hidden layer kind of neurons are all set right as expected, if it is giving the output, hence I would like to make this as a real time neural networks. So now I can give the realistic problems, hence it will produce as an accurate output. It will produce accurate output. So without giving training, it may or may not be produce the accurate results. Okay, so just now we had an example with an addition operation. So in the period of training, suppose I supposed to add two numbers and again in another possible 3 numbers, 4 numbers, 5 numbers. So in this, how many numbers I wanted to be added in the period of training. So all it is performing well. Now in the realistic, in the real time, if I give 20 digits at a time, 20 digits at a time, definitely it will be perform a very good, accurate answer. Is it right or not? So if I am not giving training, definitely it may go wrong. Okay, so this is an example of addition operations. So like this, the concept is same, and if you go for the another model is like not for the addition operations. Yeah, image recognition. Let us assume image recognition. Image recognition. Okay. So let us assume there are two diagrams, right? So one diagram is one picture is dog, another picture is just men. Assume man. Okay, so if I give these two inputs to this mathematical model, directly is going to be recognized. This is a dog diagram, and this is a dog picture, this is a man picture. So in the period of training, I need to show this model thousands of dog pictures, thousands of dog images, right, and thousands of the human being pictures. So definitely I must train the system. Okay, so if even though that model is not working accurately, what we have to do? So our training samples need to be increased. Our training samples need to be increased. Okay, so this training, this sample, see neural networks stands for try and erase. If you get answer in one try, in one hidden layer, in two hidden layers or three hidden layers, whatever. So it's purely work out, try out. Definitely it will be work out. Okay, so what are the minimum hidden layers? Either it got 100. Okay, so it should not be less. It should not be more. If we erase the hidden layers, one single digits now, so what will happen? Definitely it won't recognize as the accurate picture. If we give more, it will be only recognizes that diagram only. If we are changing that will not be recognized. So low what we call it as the number of layers or the number of hidden layers are low or the number of hidden layers are high. In two ways there is a problem. So what is the normal range? What is the normal range is 2 or 3 or 10. But this is not also the fixed numbers. So these much of hidden layers we may have in this neural networks mathematical model. Okay, so what we are doing here in the concept of neural networks, we are trying to replicate our human brain, and we are creating a mathematical model. And this mathematical model will recognize and it will create the patterns. So pattern is very, very important here. So is it an addition pattern? Yeah, definitely it will be going to produce an accurate result. If we change the pattern, suppose I have done the training part for the addition and I am trying to do it with the divide operation, definitely it will goes wrong answers, right? Why? Because we did not train with the particular pattern. If even though some samples or some inputs or some trials we have done, so definitely the pattern is going to be recognized. Oh, this symbol is for addition operations, and this symbol is for division operation. This symbol is for subtract operation. So I need to perform this. So like that, the patterns will be arranged. The patterns will be set right. Okay, so within this neural networks. Okay, one? Right. Next slide. You will longer. Right. Look at this simple decision via perceptron. So in the neural networks arrangement, okay. So my intention is to be, sir, is slide normal board on? Indama. So each and every neuron is connecting all the neurons of hidden layers. So here I am going for image recognition. So in the process of image recognition, let us assume here how many neurons are there? In the input layer there are 4 neurons, right? 4 neurons, or we can also call as 4 nodes as well. Neurons, nodes, all are same here. Okay? So each and every neuron is going to store one value. That value is called activation. That value is called activation. Let us assume here this is A1. A1. So this neuron is holding which value of what? Activation 1. Okay, and this is like this A2 and A3 and A4. Okay, and each and every neuron is connecting with other neuron, right? So each and every neuron is connecting with other neuron, so it can have the strength. It can have the strength, so that strength we are taking it as weights. So let us assume if it is a W1 and so on, W2, W3. So how many connections are there with this first neuron? Every node, whatever the connections are there with the other neurons, all can be represented as weights. Okay. So here coming to the output layer. See, the input layer and output layer is direct. Input layer and output layers are direct. So how many output neurons are there here to recognize it? Two images, right? So there are in output layer there are two neurons only. There are two neurons. Either it may be that neuron is, see, if the first diagram is belongs to A1. First neuron is belongs to first picture according. So this will be if this model has been recognized, it is a dog, and this will be output as 1 and this will be rated 0. Once the output as dog, so if the output as another one, so it becomes 0 and this becomes 1. Okay, and why, how the middle layer arrangements, the middle layer arrangements. See, let us assume here this picture. See how we are going to calculate the images. Images is nothing but just like a pixels, right? Pixels. Let us assume this image pixel is 728. Let us assume this pixel size is, this image size is 728 pixels. Okay? Okay? So 728 neurons are going to be arranging in the input layer. 728 neurons are present in the input layer. Okay? 728 neurons will be arranged in the input layer. Okay, right. And next, in the output side design, in the output side layer, we are giving only two diagrams. We are doing it for the classification. So output layers in the output layer, how many neurons are present? Direct only two neurons. So 728 input neurons are there, and in the output layer only two neurons are there, and the remaining in the hidden layer, what will be the arrangement? See, the hidden layers are how many? No one can know. So in the hidden layer, how many neurons will be present? So directly we know in the input layer, whatever the image size is there, that much of neurons are arranged. That much of neurons are there in the input layer. Okay, and output definitely we must know. So we are testing that whatever the model we have been generated, right? We have been computed, right? That model we are trying to give. So I am passing only two diagrams, two pictures only, whether it may be a dog diagram or human diagram. Okay, so in output layer there are only two neurons only. Okay, and my question is here, how many hidden layers will be present in this arrangement, and how many neurons will be present in this arrangement? So that we cannot tell. So nobody can guess. So no one can answer this question. So, but the arrangement there is a chances of pyramid arrangement. Pyramid. You know what pyramid? Pyramid arrangement. So pyramid arrangement is nothing but here input layer 728 neurons are present, and in the hidden layer this is IP, and I am trying to doing it in hidden layer. So less than of 728, less than of 728 and greater than of output neurons. Less than of 728 and greater than of output neurons count. So let us assume 128. 128 maybe in the first hidden layer. Next hidden layer may be the arrangement. How many? Less than of 128, 64 let us assume, and greater than of output neurons, right? So 2 means 64 is greater than of 2 neurons, right? Yeah, this is one more layer in hidden. Okay, and next 64, 32 maybe. Next 16, next 8. So likewise, a pyramid structure is going to be taken place in the area of hidden. These much of neurons will take place in this arrangement. So, like this, neural networks are going to be designed for every problem. So this is a basic, problem classification. What we have done in the process of classification. This is an example. So in the real world, there is only classification problems. No, we are having plenty of problems, right? So in each and every area, what we have, the neural networks. The neural networks is supporting to solve all the real-time problems. What is the power of these neural networks? It is going to creating a new model. It is going to creating a model, computational model, and that model is going to be creating and recognizing the patterns. Patterns are very much important. అంటే pattern ని గుర్తుపట్టడం and as well as pattern ని create చేయడం is the secret of success of neural networks. Are you all following me, right? Okay. So this is the main theme of the neural networks. So everybody understood? So why, what are the neural networks and what is the main intention of these neural networks? How these neural networks are going to solve the real problems and actually what's happening in the neural network. Neural networks are belongs to biological neurons? Biological neurons? No. So neural networks, these are all artificial neural networks, right? Artificial neural networks. So as per our discussion, neuron is what? Neuron is just like a variable. It can hold a value. So that value is called what I told you? Activations. What are those activations? How it holds the values and what is meant by this strength of the neuron? Okay? So different things are there to understand in the neural networks. So that we are trying to learn in this afternoon. Okay? Are you all following me, right? Ardhamautunda? Very good. And also, see, this much of the hidden layers are being there in the hidden layers, right? So this all calculation part will be easy for us in the form of 2 powers. So now what is the value of this? It's maybe 2 power 8 or 2 power 7, 2 power 6, 2 power 5. So the calculation part will be takes place easy, right? So we will be taking all these values in the form of 2 powers. Okay, now? Like this. Yeah, look at this diagram. A simple. Mali exit. Okay, no problem. We'll exit. Yeah. If we see a single neuron, if we see the single neuron, look at here, input layer, in an input layer, and these neurons are connecting with the hidden layer of one neuron. Okay, please understand this diagram. So what is x1 here? x1, x2, and up to xn. These are all what? The number of neurons are present in the input layer. Okay? And what is W1, W2, W2, W2? These are all the weights. Look at here. And see in this next diagram, there is a value is called B, right? B. B stands for here bias. B stands for here bias. And look at here in the left hand side, x1 is equal to 1 and x2 is equal to 0 and x3 is equal to 1. There are three variables, right? See, in the x1 neuron, the activation value is 1. In the input side neuron, in the x1 neuron, the value of that particular the particular neuron value is 1 number. So what does it mean? What does it mean? Its value is 1. So it is participating in the particular pattern recognition. So the recognizing the pattern and creating the pattern is our main intention of the neural network. Are you following me, right? So x2 is also having one more value. So this is also either it will be a 0 or 1. So why all these neurons are storing only zeros and ones? Zeros and ones. See, mostly our neural networks are trying to whatever the activation value is coming, it is going to set right with only the two values that are 0 and 1. How it is possible, sir? How it is possible? 0 and 1. So only two values is going to be storing. Okay. But in realistic, in the hidden layers, there are lot of changes will be done. Okay. So as we all know that in the input layer we are having the number of neurons and which are having the activation values in the input layer that we all know, and in the output side that we know. Why? Because the outputs also pre-configured, right? So input and output we know, and we are giving the computing model, and the computing model is to be set right. And what are the values we are going to take in the hidden layer? What are the values we are going to take in the hidden layer? What are the values? From which value we are going to be start within this hidden layer neurons? It's completely random values. So how we are going to be trying? By taking the random values. No fixed values. Whatever the value you wanted to be done, you can take. But the input pressure and the output pressure, with the input pressure and the output pressure, our computational model will be set right within the form of hidden layers. So either in this case there is a values of the values of it must be 0 to 1. So minus infinity to plus infinity. The values are we may get minus infinity to plus infinity. The values we are going to be getting minus infinity to plus infinity. But the system is going to giving us in the form of only zeros and ones. zeros and ones. So either maybe the values are more values or less values, right? More values and less values. And here in this we are going to check the special functions which are called as activation functions. Activation functions, right? So what are those activation functions? We will see. This is the algorithm what I explained, right? So this is the process of taking the neurons and their brains. Yeah, look at here. This activation function decides whether a neuron should be activated or not. This activation function only which decides whether a neuron should be activated or not, and it helps the network to use useful information and suppress the irrelevant information. So participation of the particular neuron in the particular recognizing the pattern is completely pressurization from where input, given input, and the output in between, whatever the random values we are going to take in now. So those values are set right with this activation function. So with this activation functions, whether they are participating in the process of recognizing the pattern or not participation of the recognizing the or activating the pattern, that will be depends on this functions. Okay, so these functions are sigmoid, Thana, and the ReLU functions. Look at here. So I told you that the values may be a complete, high numbers or complete low numbers, right? So this sigmoid and this ReLU functions are suppressing these values, and they will be these functions are trying to get only in the form of two values which are 0 and 1. 0 and 1 number. So this is the sigmoid function. So it is continuously differentiable and it arranges from 0 to 1 and not symmetric around the origin. And also ReLU function, and this ReLU function is maximizing the functions to 0 to z. So all called piecewise linear functions because rectified functions is linear for half of the input domain and non-linear for the other half. So trivial for implement and sparse representation. So like this, ReLU function is helping in mostly deep learning. Okay, so this is the arrangement which we had the diagram of. That arrangement is called as feed-forward neural network. So these values we are not taking right now. These are all not taking the values on right now. So input layer and hidden and output. Just a minute, please observe this. The objective functions one. Please identify in this diagram how many activation functions are there, how many activations are there, and what is the activation function here. Please recognize.
Students, you can take 10 minutes break and come fast.
live sunny